Hey guys, welcome to Safi Mixed. In this video, I will let you know how to find the numerical values of different trigonometric functions for angles 60 degrees and 30 degrees. This can be done very easily with the help of an equilateral triangle. Therefore, I first draw an equilateral triangle of the form this with what this is denoted with letters A, B, C. Being equilateral, the side lengths are equal and I denote it with lowercase a. We further know that the angles, the vertices of an equilateral triangle each equals 60 degrees. Therefore, I write them here as 60 degrees. Now, if I draw an angle bisector from vertex C on side AB like this one, the dashed line, then I denote the point of the angle bisector on line C with D, and the angle bisector makes with the side AB is 90 degree. Therefore, the triangle ADC is a right triangle. Since the dashed line or the line DC is an angle bisector, therefore the angle at this side is 30 degree and the same is true about this side. Now the length of side AD is then equal to A divided by 2. So we know the lengths of two sides in the interior angles of this right angle triangle. Therefore, I can use this triangle to find the values of different trigonometric function. However, to do that, I first need to find the length of side DC. And that I can use by using Pythagorean theorem, because according to Pythagorean theorem, since this is 90 degree, therefore this side AC is hypotenuse, and we know the square of hypotenuse equals the square of the other two sides of a right angle triangle. Therefore, for triangle ADC, I can write AD squared plus DC squared equals AC squared, from which I can find the length DC by writing this equation in the form DC squared equals AC squared minus AD squared. Now putting the values A in A by 2 for AC squared and AD squared, I can write AC squared minus A divided by 2 whole squared. And I can simplify this to write it as 4A squared minus A squared divided by 4, and 4A squared minus A squared equals 3A squared. Therefore, I can write 3A squared divided by 4. Now, DC squared equals this thing. If I take the square root of this equation, I can write DC equals square root 3A divided by 2. So the length of side DC is in fact equal to square root 3A divided by 2. Now we know the lengths of all the three sides of triangle ADC. Therefore, I can solve to find the values of different trigonometric functions for angle 60 degrees and angle 30 degrees. Now, if I treat the side AD as the base of this right angle triangle, then I'll treat this angle, that is 60 angle, as the argument of the trigonometric function. And if I treat the side DC, I will treat 30 angle as the argument of the trigonometric functions. So I first treat the side AD and write the values of sine 60 degrees as the ratio of side CD, because this is now the perpendicular to the hypotenuse, and write this as CD divided by AC, and putting the values for CD or DC equals square root 3A divided by 2, the whole divided by the value of AC, which is A, and I can rewrite this as in the form square root 3A divided by 2 multiplied with 1 over A. So I can cancel the A in numerator with the A in denominator, and am left with square root 3 divided by 2. So sine 60 degrees equals square root 3 divided by 2. Similarly, we know that base by hypotenuse equals cos theta. Therefore, cos 60 degrees equals AD divided by AC, and putting the values, AD equals A divided by 2 and the AC equals A, so I can write this as A divided by 2 multiplied with 1 over A, and I can cancel the A with A and the numerator and denominator, and that leaves me with 1 over 2. So cos 60 degrees equals half or 1 by 2. Similarly, I can find the value of tangent theta either by making the ratio of sine to cos or making the ratio of perpendicular to base. Whichever way you go, I write this as the ratio of perpendicular to base, and putting the values, I can write square root 3a divided by 2 the whole divided by a divided by 2, and putting them in the form of two factors, I can write square root 3a divided by 2 multiplied by 2 divided by a. Again, I can cancel the a with a and the 2 with 2. That leaves me with square root 3. So tangent 60 degrees equals square root 3. Now, if I treat side DC as the base of this triangle, then I'll treat 30 degrees as the argument of sine functions, and AD would become the perpendicular. Using this definition, I can write sine 30 degrees equals AD over AC. Now, you see AD is the perpendicular and AC is again the hypotenuse. So putting the values, I can write A divided by 2 the whole divided by A, which I can write as A divided by 2 multiplied with 1 over A, and I can cancel the A with A again, that leaves me half. So sine 30 degrees equals 1 by 2. Similarly, for cos 30 degrees, I can write CD over AC, because now CD is the base of this triangle, so I can put the values CD equals square root 3A divided by 2 the whole divide with A. And I can further write this in terms of two factors like square root 3a divided by 2 multiplied with 1 over a, and I can cancel the a with a. That leaves me with square root 3 divided by 2. So cos 30 degree equals square root 3 divided by 2. And again, for tangent 30, I can either take the ratio of sine and cos, or can use the side lengths, and that becomes AD divided by CD, that is that is perpendicular by base. And putting the values, I can write A divided by 2 square root 3 times A divided by 2, and that leaves me with A divided by 2 times 2 divided by square root 3a. Again, I can cancel the a with this a and the 2 with this 2, and that gives me 1 over square root 3. And using the inverse of these functions for 60 degrees and 30 degrees would give us the other three trig functions like cosecant, cotangent, and secant theta. So this way you can find the numerical values of the trigonometric functions for angle 60 degrees and 30 degrees. Thanks for watching.